In this video we will discuss what is multiple regression. So, again the same regression can be classified into simple or multiple. We will talk about multiple here. To tell you that multiple regression means it has one dependent variable and multiple independent variable. So, which means there are two independent variable and one dependent variable, that is the final marks. This data we have seen previously multiple times in our examples. So, I am using same example so that we know how the same example can be used for different models, how it is how different models predicts the score in a differently. We can compare that also. So, in attendance and midterm we already plotted this. Now, we want to predict by using this what is the final marks out of 100, which we cannot show it in this simple plot, in a 2 dimensional plot we cannot show that here. Okay, the data and the plot is not matching, but consider this is the plot. Okay. We cannot show the final marks in it. Maybe you can do for each data, say there is a data of say 45% or 40% and 80% in midterm marks. You might able to plot what will be the mark, something like that, maybe a 70 or 80, you can write the marks on top of it. That might be good for classification algorithm, not for regression algorithm. Let us see how it be used for regression algorithm. Y predict is equal to 31.45 plus 0.4 x1 and 0.2 x2, that is the linear regression model for the data we gave. Attendance is in percentage and midterm marks is here is x2. So, the first variable is attendance in percentage and second variable is midterm marks, and R equal to 0.85, R square is equal to 0.72. If you remember the correlation coefficient R, that is what computed here, the R square is this, but it is not the correlation coefficient like we did with one variable and one x and one y. Instead this is with the two variables. So, that is called regression coefficient. Okay. Let us see that. If it is 0, it means no relationship between the variables x1 and x2 to y. If that is near to 1 or 1 is a perfect relationship, perfect linear fit between x1 and x2 to y, near to 1 is good. Okay. So, it is good. So, I plotted this linear regression in Excel sheet using data analysis tool, and here it considers only the midterm marks to predict the final map score, final marks in the out of 100, and predicted value and the final actual marks. This is the predicted value, this is the actual marks, this is the predicted value, the fit is kind of okay. If you consider only the attendance, the fit is again it is good, it is not very bad. So, individually each variable is doing good, and we have seen that this variable has high correlation. We discussed that in one of our correlation matrix video, right, we remember that. So, this is good. Okay. So, these two variables are correlated and they also fit best with the final marks out of 100. So, what that means in multiple regression is, suppose you have this particular prediction value, that is the linear model learned from this 7 data, right, and you want to predict the future marks, you can use this model to predict it. Let us see what is this predictive model do for the given data, that is on the training set itself. For predicting a student 1 data, I would add 31.45 plus 0.4 into x1 is 56 and 0.22 into x2, 0.22 into x2 is 45, 0.22 into x2 is 45. If you compute this, the mark will be 63.75. The final mark is the actual mark is 70, the predicted mark is 65. So, the error is 63.75 minus 70 into square, that is the error, and if you compute the error like that for all these values and average of that error is the least mean square error value. So, then we select the best fit model. Okay. So, this is how it is computed. Let us see how it works for. If I compute that for all the models, the answer is like this. So, this value is a bit different, 63.75 to 84. It is because I ignored the values beyond the 2 decimal point, right. So, the system computes all the values and this is the correct result. So, yeah, so this says that this is best fit for some of the data, for example student number 4 it is good and also student number 6 is good, but others it is not so so great or so perfect, but that is fine, this is the model we get it, best fit model. Now using this model if it is very interesting that if you want to predict some student, you have no idea what the student is, the student has a 75 percentage attendance, also he scored midterm marks say 50, okay, something like that. So, what will be that student's performance? So, consider this data you got it, this particular data, right, this particular data, this whole table, you know, consider this whole table, consider this whole table data. This whole table data you got it from say this table you got it from historical data for last year, last 2 years data, kind of like 100 data you have or 200 students data, and you created this model, and this is the student 1 in a current semester. Okay. So, if the student 1, this is the student 1 in a current semester, he has attendance and midterm marks. Now, do you want to predict what will be the students final score in the exam. So, you apply this model. So, the students final score in exam y predict equal to 31.45 plus 0.40 into 75 percentage, that is you can use 75 as it is, and plus and 0.22 into 50 midterm marks. Why I asked you to use as it is, maybe the system would have used as it is. So, I used actually the same mark, I did not put the convert that into a like a 75.75 something like that anyway. So, this is the mark, if you compute this is the mark the student want to get it. You know, in a current situation we may see that lot of institutes, campuses or universities are cancelling the NSEM exams. The better way to do it, let us take the students, the current students who are in the class 4th year, 3rd year or the previous historical data on particular course, take all this data and compute is there any fit by computing the midterm marks or term 1 marks and attendance or any other variable you can collect. Create a model and make that model is very accurate, high precisely doing it, then apply that model to predict the score. That will be a better way to do it. However, given the current scenario things are not that way, things are computed just based on 80% marks in last year's score, or some university goes by midterm marks some value, or the students performance still midterm. Students performance still midterm is still good, you know why, because that actually proved if you compute the last 5 years data or something, the midterm mark is actually highly correlated with the NSEM marks. So, yeah, but this should be the right method to do. If you are interested, if you have data, access to the data, you can go and take the data of last 5 years students data and compute the current students data and see how it works, you know. Then you may not have the actual value, that is fine, but you can predict it as much as good. Okay. It is interesting that we saw in a simple linear regression, also the in multiple regression, there is an intercept like 31.45 in this equation, or there is some other values in the previous equation. What is this intercept means? What is the significance of this 31.45? What is this intercept? Take a moment, you know, this intercept is the line extended towards the 0 in x value, that is the where it is crossing in a y scale. That is a value good, but what does that means? Take a moment, think about it, write down the answer. After writing it down, resume the video to continue. So, intercept means with no values of x1 and x2, okay, y will predict the intercept score. The y actually gives the, if x1 is no value 0, x2 is equal to 0. So, whatever the intercept plus that value is what given in the y. Mean value of y with all independent values set to 0 is actually the intercept value. Okay, if you have to compute it, that is how you have to do it. And it can be positive or negative, okay, that is very important. So, it is very important, it can be positive. Do not try to interpret the meaning of the intercept, that is not correct, Okay. This intercept is very important for linear regression to create a best fit model, you know, but there is no meaning to it. Do not try to identify the meaning of the intercept. Some model with a better intercept, no, not really true. In educational settings, if the student is not attending the class, also he got 0 mark in the midsem, he not attend the class, what will be the final score? So, institute may not even allow the student to write exam, the final score will be 0, but the model might say 34 marks, it is not correct. If we allow the student to do that, he might get the 31 marks, we do not know. Or some cases, you know, some particular examples, there is a possibility that a person may not even come to work at all, and a person may not able to perform the duty, still he might get some basic minimum wage, you know, as per the norms or something like that. That kind of, that is a minimum wage, anyone can get it, even if you work, do not work, that can be an intercept. But do not try to interpret the meaning of this intercept, that is the idea. Okay. So, maybe if the x values cannot be 0, like midsems and items cannot be 0, then do not even try to interpret. So, in educational settings, do not try to do that. Most important thing in linear regression or simple regression or multiple regression is the most important thing is y is say c plus x1 w1 x2 w2. So, now you thought I said do not interpret the meaning of c. What is w1 and what is w2? What is the significance of w1 and w2? Keeping the other value constant, consider the x2 is same, okay, keeping the other value constant. How much the x1 as relationship with y is defined in the w1. I said in the last video what is the advantage of using linear regression or regression model is to create the indicator of each variable with the y, that is called the indicator, right. If you keep all other variable values constant except that variable x1, all other x2, x3, x4, all other variable keep constant, this particular relationship or relationship between x1 and y is given in this weight. Similarly, if you keep all other things constant except w2, the relationship between x2 and y is given in the weight w2. That is how the relation varies. If it varies by 1, this will vary by, say, if it is 0.8, if it is 100, this will be 80, something like that. Okay. You can interpret the meaning of the weights not c, in this indicates how strongly this particular variable is correlated with the y, keeping all other variables constant. Okay, that is the linear regression. Thank you.